Hello guys, in this video we'll be looking at the cumulative generative functions on a binomial distribution. So we'll be dealing with mean and variance, variance of binomial distribution. So using cumulative generating function, that is cumulant generating function. So let us try to solve this. So what is cumulative generating function? Cumulative generation function is nothing but the logarithm of characteristic function, right? So it is defined with kx of t. Kx of t is nothing but the ln of phi x of t. So let us come into the solvation part. So what is it? So let us take q of x of t such that is nothing but the expected value of e power itx. So we have to do for the binomial distribution, right? So sigma x is equal to 0 to infinity no 0 to infinity e power itx into ncx p power x q power n minus x. So the powers are equal, so we can combine the base values, that is sigma x is equal to 0 to infinity e power it into p whole power x into ncx q power n minus x. So we have already told that if it is in the ncx p power x q power n minus 1 can be written as p plus q whole power n. So here we can write it as p into e power it plus q whole power n, which is equals to phi x of t. So what is kx of t then? That is cumulant. Kx of t is nothing but the ln of phi x of t, right? So what is that? Then it will be ln of p into e power it plus q whole power n. So in logarithm, if it is ln of x power n, it can be written as n into ln of x. So here we can write it as n into, so n term comes down ln of p into e power it plus q. So kx of t. So we have generated the binomial function in cumulant generating function. So now let us try to find the raw moments. Raw moments is nothing but the first order derivative, that is mu1 dash is equal to d by dt of kx of t such that t equal to 0. So let us do that. D by dt of, so n ln of p e power it plus q or q. So we have to remember the formula that d by dx ln of x can be written as 1 by x dx. So hope if you remember this formula, we can write this formula as it is. So that is n is the constant term, get the n back. So we can write the entire term as 1 by p into e power it plus q. So we have to differentiate for this value also. Then what will be getting? So p will be getting p into e power it. So we have to differentiate for the upper term also, that is I. So this is a term. So what we have get? N into p into e power it into I by p into e power it plus q such that t equal to 0, t equal to 0. So now substitute t equal to 0. What will happen? This term will be removed, this term will be removed. What will be the remaining term? N into p into I by p plus q, p plus q. So what is p plus q? P plus q is nothing but the it will be value 1, right? So therefore we will be having n into p into I, that is mu1 dash. So mu1 dash is nothing but the npi. So I already told that if in case the mu1 dash or mu2 dash is in the power of with the values I or negative, we have to go into the theory part, that is we have to remove the I value, imaginary values. Mu1 dash is equal to minus I into d by dt kx of t. So minus I into, what is d by dt is nothing but the n into p into I, will be resulting to np, that is mu1 dash. So now let us find the variance. So variance is nothing but the double order derivative. So that is d square kx of t by dt square such that t equal to 0. So d by dt of, we have already differentiated d by dt of kx of t such that t equal to 0. So d by dt of, what is the k, the first order derivative? So first order derivative is nothing but this term, this entire this term we have to place it there, that is n into p into e power it into I by p into e power it plus q, that is n into p into I into e power it by p into e power it plus q. So if you remember the 12th class problem, 12th class general formula, that is d by dx of u by v is nothing but the v du by dx, this is x term, or d by dx minus u dv by dx by v square. Just remember this formula, okay, don't get confused, we have to use this formula now. So what are the constant terms here? NPI is the constant term, so you get NPI outside, and we have to differentiate for these two terms, u, and this term is the u value and this term is the v value. So first v value we will be taking, so v du by dx. So what is v? P into e power I t plus q. What is v? We have to differentiate du by dx. What is du? E power I t, so e power I t into I, right, minus we have to differentiate u. What is u? E power it into we have to differentiate dv by dx. What is dv by dx? This one, so that is p into we'll be getting p into, so q is 0, so p into e power it into the upper one we have to do, that is I. So this is the equation, by we have to do for v square. So what is v square? P into e power it plus q whole square such that t equal to 0. So now substitute t equal to 0 in the equation. Just I will so what will happen? So this term will be equal to 1, 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 and here this term will be equal to 1. So I will directly write it, n into p into y such that p plus q into I minus this term, what will happen? 1, so it will be pi by, so this term will be 1, p plus q whole square. I have already told you that p plus q is equal to 1, right? So what will be the left remaining? NPI of this term will be 1, I minus p of I by p plus q is nothing but the 1 value. So here take the I outside, NPI of 1 minus p of I. So what will happen if I into I will be having root of minus 1 into root of I minus 1 will be 1, right? So here we will be getting np of 1 minus p. So if you remember, what is the q value here? Q value is nothing but the 1 minus p, that side. So we can represent np q. So this is the mu value, that is mu2 dash value. So therefore that is the variance we have done. So what is the mean? Mu1 dash is equal to np and mu2 dash is equal to npq. So what we have done in this video, so maybe this video, this sum might come in the exam, just try to concentrate it, because it has two different values, that is it is in the logarithm form, and also we have used the division differentiative. So what we have seen in this video so far, we have calculated the mean and variance of binomial distribution using cumulative generating function. So we have generated the cumulative generating functions using the binomial, that is n into ln of p into e power it plus q. Then later we have into the deriving the raw moments. So in raw moments we got the I value, then we went to the theory part and removed the I values with the imaginary values. Then later we got just mu1 dash is equal to np. So then we went to find the variance. Variance is nothing but the double order derivative. So we have derivative, then we have used the formula dx of d by dx of u by b is equal to v du by dx minus u dv by dx by v square. Then we have substituted the value, then we have substituted the t is equal to 0, then we have solved it, and we have substituted the q value. So this is the actual process to find the cumulative generating function for a binomial distribution. Thank you.